And this is a new form. I don't think that you've thought about integrating expressions like this in this class before. So it's a new form, and I want to show you how to do it, how it's related to trigonometry. Well, it's related to trigonometry through that exact picture that we have on the blackboard. After all, this a squared minus y squared is the formula for this arc. And so what I propose is that we try to exploit the connection with the circle and introduce polar coordinates. So here, if I take and measure this angle, then there are various things you can say, like the coordinates of this point here are a cosine theta a. Well, I'm sorry, it's not. That's an angle, but I want to call it theta 0. And in general, you know that the coordinates of this point are a cosine theta a sine theta if the radius is a, and the angle here is theta. So x is a cosine theta, and y is a sine theta, just from looking at the geometry of the circle. So let's make that substitution. Y equals a sine theta. I'm using the picture to suggest that maybe making this substitution is a good thing to do. Let's follow along and see what happens. If that's true, what we're interested in is integrating a squared minus y squared, which is a squared. We're interested in integrating the square root of a squared minus y squared, which is the square root of a squared minus this a squared sine squared theta. And, well, that's equal to a times the cosine of theta, right? That's just sine squared plus cosine squared equals 1 all over again. It's also x. This is x. And this was x. So there are a lot of different ways to think of this. But no matter how you say it, the thing we're trying to integrate, a squared minus y squared, is under this substitution, it is a cosine of theta. So I'm interested in integrating the square root of a squared minus y squared dy. And I'm going to make this substitution. Y is a times the sine of theta. And so under that substitution, I've decided that the square root of a squared minus y squared is a cosine theta. That's this. What about the dy? Well, I'd better compute the dy. So dy, just differentiating this expression, is a cosine theta d theta. So let's put that in. dy is a cosine theta d theta. Okay, making that trig substitution, y equals a sine theta, has replaced this integral that has a square root in it and no trig functions with an integral that involves no square roots and only trig functions. In fact, it's not too hard to integrate this now because of the work that we've done. The a squared comes out. This is cosine squared theta d theta. And maybe we've done that example already today. I think we have. Maybe we can think it through, but maybe the easiest thing is to look back at notes and see what we got before. That was the first example in the hard case that I did. And what it came out to, I used x instead of theta at the time. Okay. So this is a good step forward. I started with this integral that I really didn't know how to do by any means that we've had so far, and I've replaced it by a trig integral that we do know how to do. And now I've done that trig integral.